Okay, let me take a container. Some n moles of gas I'll fill up. Monoatomic gas, time being, let it be. Then, oh, this one, if n moles are there. So then, shall we call that as, shall we say that energy, temperature T initially, this one. So what do you mean by n moles? How many molecules can we calculate? Yes, we can calculate, no? So therefore now what I do is like, this is some gas, let me take it. I'll increase the temperature. Number of moles will be as it is, no? Number of moles will remain as it is. I increase temperature, say T dash. So same gas. Tell me what will happen to RMS speed of molecules? Will it increase or decrease? So just now I concluded, no, if I increase temperature, then speed of all molecules will increase, no? Speed of all molecules will increase. So therefore what happened to RMS speed of molecule will also increase. If RMS speed increases, what will happen to total energy of gas must increase. So therefore, how the int G is? Int G is directly proportional. Int G we denote symbol by directly proportional temperature. So as temperature increases, int G I'll increase, I say that one. Okay, next after this. No, what we are considered monoatomic gas molecule. Let's see that what do you mean by monoatomic? Monoatomic gas. So monoatomic gas means something like a small tiny sphere. So this will be x-axis, y-axis. This will be z-axis. Then it will have a speed along x-axis, y-axis, z-axis. Then it will be spinning omega x, omega y, omega z. It will be also having a spinning. I think try to understand now. It will be moving in a space and it will be spinning about x, y, and z. What is the overall kinetic energy of this one? So we know what is the radius of the sphere. Radius of the sphere will be, mass of the molecule will be very small, no? Compared to distributed molecule. So what happened to moment of inertia about x, about y, about z should be equal to 0. Any reason for this? Because radius is very small. So what is moment of inertia? 2 by 5 mr square. Since r is very small, that's why moment of inertia is negligible. I'll write all rather than telling like a story, no? Let me give that one. So what is Ix? 2 by 5 mr square. Since r is very small, so therefore so this molecule, what all energy it will possess? It will possess only translational kinetic energy, no rotational kinetic energy. What is the translational kinetic energy? No? So KT will write it. Translational kinetic energy should be half mvx square. No, according to Maxwell's law of distribution of energy, what all the molecule that will possess energy, that energy will be equally distributed among each degree of freedom. It says, suppose say this molecule is having 9 joules. 3 joules will be utilized to move along X, 3 joules utilized to move along Y, 3 joules will be utilized to move along Z axis. So therefore, from Maxwell's law of distribution of energy. So what is the Maxwell's law? Maxwell's law of equipartition of energy. The total energy of molecule will be equally divided among each degree of freedom. Next, what is a degree of freedom definition? Number of independent ways in which a molecule will possess energy. I'll come to this. So let me just first give a description of this one, because it'll be very easy for you. This will help you a lot in chemistry also. I'll give with examples, so that the degree of freedom, everything will come. Okay, this is what it's telling. Okay, now according to Maxwell's law of equipartition. So what I can say that Vx square equal to Vy square means these all these energies must be equal. So what all it will possess energy that will be divided equally among each degree of freedom. This is what it's telling. So therefore, like this monoatomic gas molecule, we can put it here now. What is the, suppose, let me take that gas, monoatomic gas. Let me take a monoatomic gas. It's having a mass m and it will having a speed equal to Vrms. Then what is the kinetic energy of this? We'll write it as half m Vrms square. So shall we write in this way? So means something now, what we are trying to do, we are trying to relate temperature with RMS speed. Already we know RMS speed. RMS speed is equal to 3 RT by M. We are able to bring that one. So how to correlate all these particular quantities? So one thing from Maxwell distribution of energy, I am able to bring this particular thing. So what all that energy, monoatomic gas molecule that it possesses, it is only translational kinetic energy. So what is KT? KT, I should call it as translational average translational kinetic energy of molecule. How to introduce this to the particular thing? How to correlate this particular thing? So what I do is like, VRMS. Can I bring this particular form? What is small m? Not molecular mass. Small m is what? Mass of molecule. So can we express in this term? So this average translational kinetic energy, what you can write of m into Vrms square. So write it now. What is Vrms square? So 3 kT by m. Now this is very important. So finally, what do we get? 3 kT by 2. So what is that average translational kinetic energy? It depends upon the temperature is telling. K is not kinetic energy, Boltzmann constant. Please. Now, according to Maxwell's law of equipartition, what is telling? The total energy of a molecule will be equally divided among each degree of freedom. So what is the total energy of the molecule now? 3 kT by 2. And what you should call this is average translational kinetic energy. Already has shown like this. Here I'm bringing it, Once again, I'll call average translational kinetic energy of a molecule. According to Maxwell's law, that energy will be equally distributed among each degree of freedom. What is the total average translational kinetic energy of molecule? 3 kT by 2. Then How many degrees of freedoms are there? 3 degrees of freedom, I'll say. What do you mean by degree of freedom? Number of independent ways in which a molecule can possess energy. So here, so how much we'll get here? Kt by 2, Kt by 2, and this is Kt by 2. Add up all this, 3 Kt by 2. This is for monoatomic gas molecule. Means now I'll take hydrogen, then I'll take oxygen. Both are at same temperature, both the gases. What is the average translational kinetic energy? Will be same, no? So shall I say that the average translational kinetic energy of different gases at a given temperature must be same, because K is a Boltzmann constant 3 by 2. That is this 3 kT, 3 K by 2 is a constant for all gases. Temperature, if all gases are having same temperature, then what is the average translational kinetic energy? Should be constant, that one. That's what he's saying. Able to correlate. Okay, this Maxwell's law of equipartition is very important here. So means now you take tennis ball, some cricket ball, anything. You throw it, you throw vertically. You throw with 9 joules. What will happen? With 9 joules, it will move vertically up. But molecule will not be like that. If you give 9 joules, what it will do? With that, a part of that 9 joules, like a 3 joules, it will use to move along X, 3 joules, it will move along Y, 3 joules, it will move along Z. I think the behavior is totally different, no? If you give 9 joules of energy to this, it will not utilize that all 9 joules to move along X. No, 3 joules along X, 3 joules along Y, 3 joules along Z. That's what the meaning of this Maxwell's law of equipartition of energy. You take a stone, throw it vertically up. With what energy you throw, all that energy is utilized to move vertically up. It will not move in a plane. If you throw at an angle theta, it will move in a plane. But again, need not be equal. I think you know projectile, you know work point J, everything. But molecule will not be like that because they are microscopic in nature. Their behavior will be like this only. Getting the idea? The meaning of this? Sir, I'll make the molecule to move. No, you can't. Can you go and hold a molecule? Stupid, no? This thing, sir, I'll take this molecule. I'll throw along y-axis. Can you hold one molecule? Is it our science has gone to such a level? Not possible, no? So stupid ideas, leave it. How you supply energy to molecule? Tell me. Can you go take one molecule and kick it, throw it? Not possible, no? You have to supply heat. By eating only possible, no? So when you eat it up, what this molecule will do? Will gain energy. And what all it gains energy, it will divide equally among each degree of freedom. That is what the degree of freedom means here. And diatomic gas molecule will take it. Just a little bit, some thinking we have to do. Rest all we can manage very easily. Okay, next we'll go for diatomic gas molecule. So what do you mean by? I think in the next part, I'll write it here. So what is a diatomic gas molecule? So two molecules, they'll be, don't say they're connected by a rod.